Trammell Hudson, and I really like to take things apart. And most recently, I've been taking apart some IKEA lamps to try to figure out what's going on inside and how to make them better. So to get started, we're going to look at the LED driver. And for this, you'll need a Phillips head screwdriver. You'll need a 5-point security bit. You'll need a soldering iron. You'll need an Arduino. And you'll need some Python experience. If you're confused by this, don't call IKEA because this is going to void your warranty. So with your 5-point bit, undo the 4 screws by turning them in a counterclockwise direction, and which will allow you to open up the case. And inside, you'll find a bunch of electronics. In the corner is the 240 volts. Do not touch that with your fingers. The part that's really of interest is this, the CPU board and the radio board here. So if we zoom in on that, we can see it's a Silicon Labs EFR32 module. IKEA is buying this off the shelf, which is sort of nice because it means that there's a common platform across all of IKEA's Zigbee or TradFi devices. So once we understand one, we can actually extend that to support a lot of the other ones. It's not a particularly powerful CPU. It has about 256K of program space, 32K of RAM, but what it does have is a really nice 16-bit PWM, which lets you do really beautiful smooth fades for the LEDs. It also has the Zigbee radio built in, and there's enough of a documentation that we're able to reverse engineer the Zigbee stack and build our own device drivers for it. So next step, you'll need to use one 4-pin header and your soldering iron, because IKEA thoughtfully left the debug port on some of these boards. And then you'll want to connect that to your Arduino with the ground SWDIO and SWD clock. And you'll want to flash the Arduino with the SWD probe sketch that you can I linked to on my GitHub page. And then it gets a little more complicated. You'll need to use OpenOCD and GDB to push the MicroPython firmware image to the Arduino, which will then use JTAG to write it over the SWD pins into the Zigbee board. And all of the documentation, as well as all the source code, is on my GitHub tree. I'm working on trying to get this merged into the mainline MicroPython. You might ask, why? Why are we going to do this? And a lot of the talks here have talked about the need to not use the cloud, to keep the data internally. And IKEA is actually pretty good about that out of the box. Their gateway doesn't share anything about your lights to their servers. All of the control happens on your own network. But it's not open source. And by putting open source firmware on these devices, it lets us take back a little bit of that digital sovereignty that we've been hearing so much about over the past few days. That we can make these devices work the way that we want to. An example of that is, this is as dim as the IKEA firmware goes. It is not very dim at all. On the oscilloscope, we can see that it's driving that LED with a 5% duty cycle, which is much, much higher than we want for like a nightlight or something. Since we have MicroPython, we can actually replace the code that does that PWM lookup with just a few lines of code that does a logarithmic curve based on the brightness value. And it does that in response to the Zigbee, the level control message. So that this function will get called in the firmware anytime the gateway asks the device to change its brightness. And the result is something that is actually usable as a nightlight or an accent light. This is 0.1% duty cycle, and it's imperceptibly on, which makes it much, much more suitable for a lot of these applications. I do have to warn you that this software is very much in beta. It does not have all the features, but it is open source. So you can download it, you can try it, you can extend it, And you can get in touch with me and other folks who are working on these sorts of projects if you want to take control of your TradFi devices and put your own firmware on them. So I'd love to answer any questions later tonight or around, or you can check out the code on the website. Thank you.